All right, welcome back. Factoring quadratics with leading coefficient of. Okay, so now let's change this up. So we're not going to make this 1. So we're going to make this of anything except 1, right? In this case, we're going to say A is not equal to 1. 1 is the best case scenario for us, easiest of the factoring, but sometimes it doesn't happen that way. Okay, so let's see what happens. So guess and check versus AC method, right? So the AC method is going to be a new method I'm going to show you today. Um, guess and check is what we used in the past, right? The factors of C that add up to B and then go from there. Now we're going to change this up a little bit, right? So we can't just consider the factors of C anymore. So here's our first three problems in the same packet again, page 535. And let's take a look at the one. So previously I just looked at the factors of C. So factors of C, and I need them to add up to my B term. Okay, so that's changing now, okay? So it's no longer the factors of C anymore. It's now going to be the factors of A times C that add up to my middle term here. Okay, so here's two ways I'm going to show you, okay? So you can list your factors of C, right? So again, this is going to factor into two quantities. And previously I said, well, when A is 1, so if A was 1 here, it would be X and X. And now that's no longer true. Okay, so it's no longer going to be X. It's going to be some factor of this term here, right? So number 2 here. So what factor? So this could be 2x and 1x, right? Because 2 times 1 is equal to 2. And if I FOIL this, I get 2x times 1x and I get 2x squared. So no longer just x and x, now it's factors of this leading coefficient, factors of A. So what multiplies to A? And that goes into your first slots. All right, in your first position of both quantities here. Okay, so my A term happens to be 2. So 2 times 1 is my only factors here, positive 2 and positive 1, or negative 2 and negative 1. If you could leave these positive, I think that would be your safest bet. But if this was a number that's not prime, then you have multiple options to consider. So let's take a look at this one first and go from there. All right. So again, I want to break this up into two quantities. This first term, this first coefficient, I need factors of 2 to go into these two positions. There's only two factors, right? 2x and 1x is the only way I could get 2. Okay, but I'm going to write down the factors of A here, and I'm going to put my A terms here and my C terms here, and my C term is negative 2. And I want to think about what are the factors of 2. So 1 times 2 is my factors of 2. Or positive 1 and positive 2, or negative 1 and negative 2. So with your first position in your quantities, I would stress keeping them both positive if you can. Your C term now has multiple options. You can do negative 2 times positive 1, or the second option here is positive 2 times negative 1. Can also give you a negative 2, right? So if I multiply these two numbers, I get negative 2. I multiply these two numbers, I get negative 2. So now here's the tricky part. When I consider my B term, okay, none of these should add up to negative 3. Okay, I need the product of my A terms and my C terms to add up to negative 3. Let me show you what I mean. If I take positive 1, so if this is my 2, right? 2 times 1 is going to give me 2x times 1x is going to give me 2x squared. If I were to continue foiling this, I'm going to have 2x times whatever number goes there. So this is my 1x, this is my 2x, right? So I'm talking about this 2x here. So 2x is either going to multiply times negative 2, so I could put negative 2 here, and that's 2x times negative 2. Or, let me scratch that out there. Oop, a little too big. Let me get rid of that. Or I'm going to take 2x and multiply by positive 1. So in this case, where I put these factors, so these factors I choose, I'm either going to do negative 2 and positive 1, or I can do positive 1 and negative 2. Now, when a is 1, it doesn't matter which one's which, where you put them. But in this case, it does matter. Okay, so let's see how this plays out. So if I just did 2x times positive 1, okay, and I did, get rid of this, and I did 1x times negative 2. So 2x times positive 1, that means my positive 1 is here, right? So 2x times positive 1. If I multiply that, I get a positive 2x. If I put, then that means, so that positive 1 is in this position. Then I'm going to take this negative 2, my second factor, and put it into this position. Okay, so foiling this out, I have 2x times 1x, I get 2x squared. 2x times 1, I get positive 2x. If I continue the foiling process, I get negative 2x times 1, I get negative 2x, and negative 2x, and negative 2 times positive 1, I get negative 2. So I got my 2x squared, check, and I got my negative 2, check. But if I add these two middle terms, positive 2x and negative 2x, I get 0x. That does not match with my negative 3x. So that doesn't work. So I can't put negative 2 here and a positive 1 here. So I'm going to erase some of these lines here. Okay, and I'm going to scratch this out. See you later. That didn't work for me. Okay, so I'm still considering the foiling here. Okay, and I'm going to get rid of this. So erase this. Now, let's go back. Now let's do it the other way. What if I did 2x times negative 2? That means I'm putting this negative 2 in this position. 2x times negative 2, I get negative 4x. And that means I have to put this 1x in this position here. And I get 1x times positive 1x, which is equal to positive 1x. Now you can FOIL this and see what you get as a middle term. But if you just look at these, when you FOIL it, you're going to get these factors here. And what is negative 4x plus 1x? And you're going to get negative 3x. And what is your B term? B is negative 3x. So it matches. So this is my factored form of this quadratic. Let's prove this, of course. And let's go through the steps of foiling here. Okay, so 2x times 1x, 2x squared. 2x times negative 2 is negative 4x. 1x times 1 is positive 1x. And positive 1 times negative 2 is negative 2. I'm sorry, just negative 2, not 2x. And I have some like terms here, so I'm going to rewrite this as negative 2x squared, negative 4x, positive plus 1x is a negative 3x, and then bring down my negative 2, and you have a match. So there's a lot of mental math going on here, right? So you need the factors of your A term, you need the factors of your C term, and you need to start multiplying different combinations of your A and C to get your middle term there to be negative 3. Okay, not easy, okay, but you can get used to it if you do a bunch of, if you do a lot more examples, and we will. But I want to show you the same problem using a different technique, and this is called the AC method. All right, and feel free to use any technique you have learned or know. And if it's a lot easier, then definitely show me, okay? So here's the AC method. So AC method, and again, choose any method you like. I'm going to multiply my A times C, and I get positive 2 times negative 2, and I get a times c, right? So positive 2 times negative 2, and I get negative 4. And now I want the factors of negative 4 to add up to my b term, which is negative 3. So, okay, so I got negative 4 times positive 1. Multiplies the negative 4 and adds up to, and if I add these, I get a negative 3. The other option could have been a positive 4 times a negative 1, which would add up to a positive 3. I could have had a positive 2 times a negative 2, which also multiplies the negative 4, but that adds up to 0. So, right, this is the multiplies part, and this is the adds part here, right, when I break this down. So, of these options, which one is giving you a b term of negative 3? And it's this first one that we chose here, right? So, negative 4 times positive 1 is my negative 4, check. Negative 4 plus positive 1 is my negative 3, check. So, here I am. I'm going to take the first term and the last term, those don't change, and I'm going to break up this middle term into two separate terms. So I'm going to write this as negative 4x. I'll use a different color here. I'm going to write negative 4x plus 1x, and I'm getting that right from here. Now that I have my trinomial into 4 terms here, I'm going to break this up and factor by grouping. I'm going to factor out a 2 from 2 and 4, and an x from x squared and x. So factor out a 2x here, factor out a 2x here, and I'm left with x minus 2. Great. Next one, I have a positive 1 here. So I'll always factor out a sign. At the very least, I'm going to factor out a positive 1, and that happens to be the most I can factor out from here. And once I factor out the positive 1, again, I'm left with x minus 2, right? 1 divided by 1 is just 1, and negative 2 divided by positive 1 is still negative 2. And voila, they have a common factor of, there's an x minus 2 here, there's a quantity of x minus 2 here, so I'm going to factor that x minus 2 out, and I'm left with 2x plus 1. Which, if I go back one slide, I should have the same thing. So 2x plus 1 times the quantity, so the quantity of 2x plus 1 times the quantity of x minus 2, or quantity of x minus 2 times the quantity of 2x plus 1, and there's no difference. This is the same thing as writing this, right? So by the associative property of multiplication, doesn't matter which term I write first or second. All right, so here's guess and check versus the AC method. I'm going to do another example. This video is going to be a little bit longer, but let's give it a shot. All right. Now, some of these problems that we're doing are, the numbers are prime, making it a little easier. And I'll get to, maybe we'll do a second video of this one. All right, so guess and check. So here's how I would think about this, right? So I know this is going to break up into two quantities. The products of factors of 3 are 3 and 1, right? So 3m times 1m is going to give me my 3m squared. So 3m and 1m have to go in those locations. What I need to consider now are the factors of negative 3. So negative 3 and positive 1 are factors of negative 3. Or positive 3 and negative 1 are also factors of negative 3. Okay, so you have two choices. So the factors of negative 3 are negative 3 and positive 1, or positive 3 and negative 1. And you're going to play with these factors first. Okay, so I'm going to list them here, and it doesn't matter which ones you choose. I'm just going to go with this first one here. So negative 3 and positive 1. So remember, when you FOIL, you're going to do 3m times whatever number you put there. So what do you want the 3m to multiply with? Let's say I multiply 3m by negative 3. That means that negative 3 is going to take this position here. So I'm going to write this in red, negative 3. So negative 3 goes there. And if I do 1m times 1, then this positive 1 is going to go here, right? Because when I FOIL, the last term, so 3m times negative 3, and these two terms will multiply as well. So, does this work? 3m times 1m, 3m squared. 3m times negative 3 is negative 9m. 1m times 1m is positive 1m. Positive 1 times negative 3 is negative 3. Combine like terms, and you get negative 8m minus 3, which works. Now, do I have to FOIL this whole piece to like really figure this out? And the answer is no, right? And here's how. So if you do 3m times negative 3, right here is where I would write, okay, this is negative 9. 1m times 1, well, this is negative 9m. This is going to be 1m. If I add these two together, I get my negative 8m. Check. Okay, so let's do the same problem again with the AC method. So here we are with the AC method, right? So here's my A, here's my C. So A times C. So positive 3 times negative 3 gives me negative 9. Factors of negative 9 that add up to my B term. So adds up where B is negative 8. So factors of negative 9 are positive 1 times negative 9, negative 1 times positive 9, negative 3 times positive 3, right? These are all factors of negative 9. Positive 1 and negative 9 adds up to negative 8. Negative 1 and positive 9 adds up to positive 8. Negative 3 and positive 3 adds up to 0. Which one adds up to the negative 8? This one right here. So I'm going to rewrite 3m squared minus 3. Break up my negative 8m into positive 1m and 9m, right? Because positive 1m and negative 9m simplifies to negative 8m. So all is legal here. Nothing's changed. I just turned this negative 8m and I broke it down into two separate terms, which simplifies to negative 8m. Okay? Factor by grouping. Again, it doesn't matter if I put my positive 1 here or my negative m here. Same difference. All right, so here, 3m squared plus 1m. The only thing I can factor out here is m. And that leaves me with 3m plus 1. Okay. Here, the second group starts with a negative. Always, always, always factor out the sign. So I'm going to factor out a negative. Negative what? So 9 and 3 has a common factor of 3. So I'm going to factor out negative 3. So if I factor out negative 3 from here, I'm left with positive 3m. If I factor in negative 3 from here, I'm left with a positive 1. Well, what a coincidence. Here's my positive 3m, 3m plus 1. Here's another 3m plus 1. So I'm going to factor out the 3m plus 1, 3m plus 1, factor out the 3m plus 1, and I'm left with m minus 3. And if I go back to the other one, 3m plus 1, m minus 3. Check. So both techniques work. 18 minutes in, we're a little further then, but this is a huge topic, so let's take a little time with this. Okay. All right, so now, again, we'll do this both ways. So 16, r squared minus 8r plus 1. So here's an example where now 16, the leading coefficient is not a prime number. So I have to play with this one. So I can use 16 and 1. So I have to do 16r and 1r, right? In here, 16r and 1r. And if I multiply that, I'll get my 16r squared. So that part, these factors of 16 would work there. I could also scratch that out and scratch out the 1, and I could make this, rather than using 16r and 1r, I could also use 4r and 4r, and that would also give me 16r squared. Or, well, wait a sec, 16 also is 2r and 8r, so get rid of 2 here, oh, sorry. Put 2 here and an 8 here, and that would also give me 16r squared. So I have 3 different possibilities here to put in my first term. So which one do I choose? And there is no, this is where you guess and check. And through practice and practice and practice, unless these numbers in the middle are really big, I probably wouldn't do 16r and 1r. I would probably choose either 4r and 4r or 2r and 2r. All right, so let's slide this over a little bit. And I'm going to choose, I'll go with the first set here. I'll go 4r and 4r and see what that works. Well, the last number is positive 1, and that I love because the only two factors are of 1 are 1 and 1. So either positive 1 and positive 1 or negative 1 and negative 1, right? Because a positive 1 times a positive 1 is a positive 1, and a negative 1 times a negative 1 is a also positive 1. So if I do 4r, so I'm going to get rid of these for a second. And if I do 4r times positive 1, I get a positive 4r. If I do 4r times positive 1, again I get a positive 4r. And if I add these two up, I get a positive 8r. Okay, that's close, but I don't want a positive 8r. I need a negative 8r. So I'm going to change these factors. So the factors I said were positive 1 and positive 1, or negative 1 and negative 1. Right? Factors of positive 1 times positive 1, or negative 1 times negative 1, all give me positive 1. So the two positives gave me a positive 8r, not working. 4r times negative 1r, or I'm sorry, 4r times negative 1 is negative 4r. 4r times negative 1 is negative 4r, and if I add these up, I get a negative 8r, and that's exactly what I want to check. So get rid of this. So my factors here, and we'll just start this one over, why not? So when I break this up into my two parentheses, that 4r goes here, this 4r goes here. And when this 4r is multiplying with negative 1, since they're both the same number, it won't matter where you put it. So double check, 4r times 4r is 16r squared. 4r times negative 1 is negative 4r. Negative 1 times 4r is negative 4r. And negative 1 times negative 1 is positive 1. Combine like terms. And you get back to your middle, to your original. So your answer of this quadratic in factored form is 4r minus 1. The quantity of 4r minus 1 times the quantity of 4 minus 1, which also can be written as the quantity of 4r minus 1 squared, since there's two of them. All right? And now with the AC method, all right? So multiplying a times c. Here's my a, here's 17, here's my c. Positive 16 and positive 1 is a positive 16. Factors of positive 16 to add up to negative 8r, or negative 8. So negative 4 times negative 4 multiply to positive 16, and negative 4 and negative 4 add up to not positive 8, but a negative 8. And I definitely shortcutted this one a little bit because I was able to see from the last problem that we did that this is what's going to be the numbers here. So negative 4 times negative 4 is a positive 16. Negative 4 plus negative 4 is a negative 8. Right? So the factors of the a and c, so the factors of a times c, or 16 times 1, that add up to my b term. Right? So your a term doesn't change and your c term doesn't change, but what I'm going to do is break up my b term into negative 4r and negative 4r. Split down the middle here. 16r squared minus 4r, I could factor out a 4 and an r. So I'll take a 4r from both of these, and I'm left with 4r minus 1. And my next term starts with a negative sign, so I'm definitely going to factor out a negative. Can't factor out anything, so I'm just going to factor out negative 1 and divide by negative 1, divide by negative 1. This will give me a positive 4r, and positive 1 divided by negative 1 is going to give me negative 1. And now I have 4 minus 1 here, and a 4r minus 1 here, which I'm going to factor out from both of this, and I'm left with 4r minus 1. And what's left? Another 4r minus 1, or the quantity of 4r minus 1 squared. And either one of those are the answer. All right, so we did a few, and we're 24 minutes in, so let's have fun with one more. Now here's 3 more examples on that page, and I'm going to focus on number 10 here. All right, so number 10. My a term is 8, which means there's multiple factors of 8, right? 1 times 8, 2 times 4. My c term is 24, so there's multiple factors of 24, right? 1 times 24, 2 times 12, 3 times 8, 4 times 6. So there's a lot of There's a lot going on here. And this is where the guessing check could be a little tricky here, and you might not get it right away, but the AC method might be a little easier, except that sometimes the numbers get a little large when you use the AC method. So when I do 8 times 24, that's a big number, okay? 8 times 24, and I get 192. Now I got to think of factors of 192 that add up to a -4. Now, you might know off the top of your head, and great, but I feel like you're going to play a little guessing check here and try to figure out what goes into 192. All right, so knowing some divisibility rules will help. Like what's divisible by 2, what's divisible by 3, and if you don't know them, just Google them, look them up, and keep a couple of those in mind, and they will help. So I know I can divide this by 2 because it ends in 2. And I can divide this by 3 because 1 plus 9 is 10, 10 plus 2 is 12. So the sum of these three numbers is 12, and 12 is divisible by 3, so 192 is divisible by 3. All right, so some rules like that too, okay? But I'm going to try the other way. So I have 8 factors of 8, factors of 24. I'm going to play with 4 times 2 just for no other reason. That 4 times 2 is the first thing that comes to mind. And 24, I think about 6 times 4. All right, so again, I know I have to break this up. And something I said in one of the first videos about factoring is this last sign is a minus sign, right? So these signs have to be different, right? And it could be plus minus or minus plus, and it won't matter. Okay, so but the order of the signs will make a difference. Okay, so I'm gonna leave these two positive no matter what, right? So if I did 4 and 2, positive 4 and positive 2. Well, I need these two numbers to multiply. So 6 and 4 have to multiply to -24. So I'm either going to look at -6 and +4, or vice versa and do +6 and -4. And I'm going to play around with both options, and there's not one option that, I'm going to play around with both of those. All right, so let's go with -6 and +4. Well, if I multiply 4 times -6, I get -24. And if I multiply 2 times 4, I get +8. And the question is, does that equal my b term of -4? Does this equal -4? And you can do simple math there, and that does not equal -4. So that is not my option. So I'm not going to multiply that because that does not work for me. However, let me multiply the other way. So these two factors can still be the answer, but let me just try this way. What if I do 4 times +4? I get +16. And what if I did 2 times -6? I get a -12. Well, if I add these up, I get this +16 and +12 is a +4. Ooh, so close. I want -4. So I'm pretty close here now. So what if I swap signs here and I make this positive and make this negative? Well, then if I do that, then let's see what happens now. +2 and +6 is +12. +4 and -4 is -16. And adding these up, I get a -4. So check, there's my b term. Okay, so let's be careful here. So this goes in the first term, 4x. This one goes in the first term, 2x, right? Because when I FOIL, I need 4x times 2x to equal 8x squared. There's that part, okay? Now, I need this 4 to multiply with this -4 here. Right? I need these two to multiply one another. Well, 4x will multiply with whatever number I put in this second position here. So if I want 4 to multiply with -4, then that -4 needs to go here, which then means that the +6 has no other choice but to go there. And if this is right, and if I FOIL this, then I should get my 8x squared minus 4x minus 24. So 4 times 2 is 8x squared. 4 times 4 is -16. 6 times 2, 16x, sorry. 6 times 2 is +12x, and 6 times 4 is -24. And you get 8x squared minus 4x minus 24. All right, not bad. And this works. So That's using the guess and check method, right? If I did not use the guess and check method, okay, and I wanted to go with the AC method here, okay, so I got 8 times 24, and I get factors of 192, all right, so 192, and I'm going to show you a little technique on the graphing calculator to figure out some factors of 192 here. So I got to my graphing calculator on the TestNav site, links online, and I'm here. So I'm going to go to y equals, I'm going to do 192 divided by, and I'm going to put x. All right, now I want to know what goes into 192. And once I do this, and if I hit second graph, right, which is second table, my first term is 0, and I get an error, right, because you can't divide by 0. So here's my second term, so 1. So 192 divided by 1 is 192. 192 divided by 2 is 96. 192 divided by 3 is 64. 4, 48. 5 is 38.4. So I'm going to ignore anything that has a decimal. And I could go down the list here and see exactly what goes into 192 evenly. So 6 and 32 multiplies to 192. 8 and 24 multiplies to 192. And just keep in mind, so when we're here, we need to figure out what adds up to negative 4. Right, so if I do a little mental math there, right, so 8 and 24 does not add up to 4. 9, 10, 11, 12, 12 and 16. Well, 12 and 16, well, 12 minus 16 is negative 4. 16 minus 12 is 4, so that works. So 12 and 16 are the two factors that I'm going to use to get my negative 4 here. So this again is going to be 8 times, this is negative 24, sorry, so negative 1 and 2. So negative 12 times positive 16 or positive 12 times negative 16 are two options to get my negative 4. And the option I'm going to choose is this one here because this one equals the negative 4. So these two multiply to negative 192 and they add up to negative 4. So first term stays the same, so 8x squared. I'm going to replace the negative 4x with plus 12x minus 16x, which gives me negative 4x, and then minus 24. Right? So this is the AC method here. And then break these down. 8 and 12, I can have a common factor of 4. Okay, and x, leaving me with 2x plus 3. And then my next one here is negative 16x minus 24. I can factor out negative 8 here. This will leave me with 2x minus plus 3, right? Dividing this by negative 8, dividing this by negative 8, right? These two make a positive. And then again, I have a common multiple of a common quantity of 2x plus 3, and then leaving me with 4x minus 8, which should be the same, but look, it's a little different. Now, there is a reason why this is a little different. Okay, 2x plus 3, 4x minus 8. If you notice 4x minus 8, 4 and 8 is there's a common factor in there. So 2x plus 3 is fine, but I could factor out something from the 4x minus 8. I could actually factor out a 4 from there, and I'm left with x minus 2. So let's see here, 4x plus 6 and 2x minus 4. I could factor out a 2 from here and be left with 2x plus 3. And I could factor out a 2 from here and be left with x minus 2. And then if I combine 2 times 2, I get 4 times 2x plus 3 and x minus 2. And I'm going to give you a second to think about this and why these came out to be a little differently. And if there's anything I could have done to make this a little easier. And the answer is yes. All right, and I'm not going to get into this one just yet for time's sake. Look at your A, B, and C values, right? 8, 4, and 24. Right, there's a common factor there of 4. I could divide 8 by 4, I could divide 4 by 4, and I could divide 24 by 4. And that's that common factor right there that I could have taken out. And that could have made these numbers a lot smaller to work with, and then factored into 2x plus 3 and x minus 2. And that would have worked just the same way, okay? But two methods, guess and check, AC method, both there. I'll definitely do a couple more examples of a second video of these, and we'll put it up there very, very soon. All right, talk to you guys soon. Sorry for a really long video on this one.